And I'm gonna do the part 1, which is the schematic for circuit 1. And as you can see, the schematic is already set up as shown on the breadboard. And now we're gonna do the testing. So when A and B is off, the output is 0. So when A is 0 and B is 1, the output is 1. When A is 1 and B is 0, the output is still 1. And then when both are 1, the output is 1. Thank you. The NAND gates and the NOR gates have already been assembled, as you can be seen on the board. So now we're gonna do testing. So when both A and B are off, so output is 0. When A is 0 and B is 1, the output is 1. And when B is 1 and A is 0, the output is still 1. Oops. And when both are high, A and B are 1, the output is 0. Thank you. We'll do part 2 concerning the propagation delay. To measure a propagation delay, we use first of all, the apparatus is set up as shown. We use the oscilloscope to measure the propagation delay. To measure propagation delay, we use the time cursor for better accuracy. And as you can see, our change in time is 44 nanoseconds compared to our interpolation one, which we got was 52.56 nanoseconds. On another note, I want to say that our graph is different from the one provided in the lab because our input and output are both 1. That's it.
I'll be explaining about the VOH and VOL, which is the output high and output low. As you can see on the graph, the blue line is of the output. So in this measurements of the typical measurements, we have predicted that the output high will be somewhere in 3.128 volt. In this graph, it says that V2 of the channel output, Vmax is 3.12, which is corresponding to our prediction, to our typical prediction originally. And for the output low, we use the cursor to measure this. In this, cursor B is put at 0 volt just for reference, and cursor A is measuring the output low of channel 2. So in here you can see the output is 160 millivolts, which is 0.16 volts. In the typical prediction we made at first, it's 0.14 volt, which corresponds to the prediction.
I'm going to conclude the experiment. So the expected result we calculate from interpolation might be different from the result we obtained from the oscilloscope. This is because there might be some resistance in the wire, therefore will affect the result. And then from the circuits here, we can know that here is the input of the current, and then here is the output. That's all. I'm going to talk about part 3. So the circuit on the diagram is being connected on the breadboard, and when the switch is pressed, the LED will light up. This is because the resistor here will help to reduce the current. Yes.
Part 4, which is construct a circuit for 3-bit majority detector, which is when the output will be high when two or more input is high. So we will be using one quad two input NAND and 1 3 triple input NAND. So this is when the inputs are low, and all the inputs are low, and this is when this is 0 0 0 inputs are low. This is when 0 0 1 0 1 0 0 1 1, the output is high. 1 0 0 1 0 1 1 1 0 and 1 1 1.